today we've got our Vice President of Sales and Marketing, Guillermo Valenzuela. He'll be joining us, as well as our guest today, who's going to be Tom Rogers. He's also going to get started with us here. We'll talk a little bit about his system, how he's done and worked with automation, and we'll go from there. So guys, how are you doing?
All right.
Doing good, Daryl. How are you, Tom?
I am well, and yourself?
I'm good, man. I'm good. Getting used to the new normal.
Yeah.
Yeah.
Not get used to it. It isn't normal.
Well, thank you for spending this time with us. We thought it was good to maybe have you here with us and share some of the experience you've had with the growers. We are recording this, so then we're going to upload it and see if other people want to view it. We've had a lot of interested people contact us regarding high frequency irrigation and pulse irrigation. Actually, I have a meeting this afternoon with the almond board and some of their guys to discuss about high frequency and see what the benefits are and how it can be used. So yeah, it's always good to have you and to hear your experience. What I'm going to do is that I'm going to go through a quick presentation. It should take me about 15 or 20 minutes, kind of like to put it in context and explain to everybody what we did and what we've been doing. And then after that, idea is that Daryl has some Q&A basically to run by you and kind of get the conversation going, and also let the people ask questions on the chat room or on the Q&A, so we can answer live questions if there's any. If not, we have some questions that we would like you to answer for us and kind of tell us your experience from the grower side regarding the technology. So I'm going to get started with the presentation here. And if you want to stop me at any point, just go ahead or correct anything that I'm saying. Please feel free. You're the guest here. So let me know when you guys can see my screen.
Yeah,
Good.
I can see you.
Good. Okay, well, so we're going to get started. The idea is, for those who don't know about the system, I'm going to do a brief description of the system and how it works. And then we're going to dive into Tom's specific case and ranch and how he operates the irrigation and how he had been using the technology. So a little bit about the company, and some of you already know this. The company was founded back in 2006 in South America, opened their office in California in 2015. We've already deployed about 7,000 units and 200,000 acres with equipment, working with 20 different distributors in the US. Most of them are in California. About 1,000 users. I think that number's up to around 1,500 by now in 5 different countries. Our main office in the US is in Fresno, in the heart of the Central Valley. That's where we hold the stock and have our support team. And recently, we've been doing a lot of API integrations. So we've been working with companies like Phytech, FarmItRx, Powwow, Polaris, Swim. So we've been integrating through the API. We honestly think that is the new wave, or what's coming. It's the collaboration between software companies and different services integrating with each other. Not one company is going to solve the whole issue. So we've been actively working on integrating through APIs with different companies in California, especially. This is a little bit of the layout. I want to say that probably Tom was one of the first 5 projects we installed in California. So that has evolved since then. We're very happy with the progress we've made throughout California. A lot on nuts, pistachios, almonds are our main crops, some grapes, berries, but now we've moved into 10 states, and we're in all sorts of crops, from cotton, hops, cherries, apples, citrus, blueberries, even cacao in Hawaii now. So it's been a wild ride, and we've been growing in the last 4 years since we opened the office, and deploying a lot of systems throughout the country. So again, I don't want to take a lot of time. A lot of people know about this. So just a refresh of memory, what drop control is. It's an online irrigation management system. I like to say it's the remote control of irrigation, and it's very good metaphor because it's kind of like the remote control to your TV. It allows you to control it remotely, basically, and schedule your irrigations and do everything from your hand, from the palm of your hand. And what it is, it's a reliable irrigation monitoring and control system that's able to connect to any sensor, operate wireless valves, pumps, and fertilizer injection systems through an easy to use online software. So what we do is basically deploy hardware we call nodes throughout the field, connected to different sensors, pumps, soil moisture, weather, temperature, all the sensors that are related to the irrigation system. And these devices have intelligence, and they communicate between them through a radio network. And then one of them has a cellular SIM card that is of the technology that's available in where the ranch is. Usually in the US, it's LTE. Right now, we're using 4G LTE for most of the ranches. If you go down to Mexico, it's mostly 3G still. But that gateway or concentration node communicates through to the cloud. We have everything hosted in Amazon Web Services. That's where we have all the services, and everything is secured. All the databases are backed up. And then from the cloud, all the information is displayed either on the app on your phone or on a software web page. And we also, as I said, have now been exploiting a lot the API feature, sending all that information into external servers. And most recently, and a very innovative feature, is that we're receiving irrigation schedules through the API. So if you're working with a company like FarmInRx or Phytech, and they have an irrigation recommendation for you, they can send their recommendation through the API to our cloud, and we execute their irrigation schedule in the field. So in short words, what it is, it's basically a cloud scheduling system, as I said before, through your phone or through a web page. It also has the capability of local control when there's no cellular signal, when something happens with the Verizon tower or the cellular tower, or for whatever the reason, you need to do a local override. There's always the possibility to do a local override of the system and run it locally. And the components that we tie into and control is, well, first of all, the pump. We start and stop the pumps. We work with electric pumps. We work with diesel pumps. There's controllers that will start propane and diesel pumps, and will do it very efficiently and monitor the pump. Then we have the flow meter, which is basically to understand how many inches we're applying into the orchard. Pressure before and after filter, to monitor how our filters are performing, how the flushing is working, and if they're not clogged or have any problems. Reservoir level control. For those of you who have a reservoir, there's possibility of monitoring the level of the reservoir, and also control starting and stopping pumps or wells to fill reservoirs based on different levels. Filter flushing is a feature that we are right now bringing out to market this month, actually. And so we are replacing those Alextronics box and giving the grower the capability of switching their flushing cycles from the app. And monitoring the groundwater level along with the flow meter. This is going to be an important piece of the information for Sigma that's coming out. So monitoring your water extraction and your groundwater level are going to be part of the regulation. And finally, some of the growers have walked into monitoring the power, monitoring how the pump is performing, what is the consumption, and basically building an overall pump efficiency curve on time, constantly. On the field, we operate wireless valves, open and close those valves, and monitor with pressure switches if there's feedback, if there's pressure, if the valve opened or not. There's always, animals, or there's pressure difference and different changes, or something that can make a valve operate, or even that pressure regulated pilot that is not operating correctly. All those factors come into consideration and can be monitored and put into the system. And then on the nutrition side, fertilizer injection, monitoring the electric conductivity that of the water that you're putting out in the field, starting and stopping the pumps. We can do fertilizer injection by time, volume, proportional. There's different ways of injecting the fertilizer, as well as the acid. It's not just putting acid out there and setting a fixed rate and injecting the acid every time you run. We get a step ahead of that and monitor the pH of the water and control the speed and the amount of the acid you're injecting depending on the pH on the water. And in the field, on the monitoring side, we have the soil moisture sensors that are crucial to monitor what you're doing, how deep the water's getting, determine when to irrigate, how long to irrigate. Weather stations that are giving us the rain in those places that it rains during the season, but ET is one of the main, and temperatures are one of the main pieces of information that a weather station gives us for irrigation management. And finally, we've been flirting around with some plant sensors, leaf temperature, fruit size, trunk size. There are different alternatives, NDVI. There are different alternatives out there to monitor plant and the trees. So there's all those sensors we've been giving a shot as well. The solution is built out of hardware and software. So it's a piece of hardware, as I said, that goes in the field, and then the software where you view the information. Hardware, we got different models. The very basic one on your right, the M1, the monitoring only unit, very cost effective, will connect to mostly any sensor with an open protocol in the market, has different inputs. You can tie into that guy, a weather station, a soil moisture sensor, a flow meter. Then you got the X1, which is the flexible node, which can connect to sensors, and actuators. So that one can control valves, pumps, and connect to sensors as well. And then finally, we recently launched the new C1, the controller, that is a more powerful processor. It has the capability of running your pumps, fertilizer injection, very precise and complex fertilizer injection, proportional injection of fertilizer. It's got Bluetooth connection, so you can run it through the Bluetooth if you have bad signal in the field. It does takes care of the filter flushing. So that new feature comes on the new RFC one. So it's basically an upgrade of the X1 with new features, and the screen is coming out here soon. So it's going to have a screen for local control. So it's a controller that is capable of taking control over the whole pump system and fertilizer injection. And then you got the software side, where we have a mobile app where the data can be viewed. You got alerts. You got a bird's eye view of the map to see what's going on. You got your irrigation information. You can schedule from the app, start and stop your pump. And then finally, your web page where you can view your information, schedule your irrigation as well. This is a little bit of what we're here today, which is what Tom was using. Scheduling his irrigation from his iPad, from his phone, setting that start time, how many hours he wants to run, or minutes in his case. If there was any fertilizer injection or pH control, all that can be set from the iPad. Originally, this was the only scheduling feature that we had, and Tom had the experience of had to do this for every single runtime. So he spent quite a few 45 minutes or so a day scheduling his irrigation because he was running so frequent. So because of that, we came up with a feature of building our own program. So you prepare a template, and based on a template that gives, you set up your start time and your end time, your sequence, your zones that you're going to run, and then the system automatically schedules it for you. So in short, what we've seen as benefits on this systems, ROI, it's averaging 1 to 2 years, basically coming by water savings, energy savings, some of the labor savings, especially in big farming operations, or at least saving time for the people that's operating in the field. And overall, if you have all this in good combination, we see that the crops improve their condition, and that improves the yields. So that's a little bit about the company, the system. I didn't want to spend a lot of time on that. Now I want to jump onto the specific case that gathers us here today, which is Rogers Ranch. This is a picture of Tom and his brother Dan, who ran the farming operation, third generation farmer. I'm going to let him talk a little bit about that. But here, maybe Tom, we can kind of do this a little bit together, and you can correct me if I'm wrong on what I'm stating. But what I want to do is introduce a little bit about the ranch information. Can you tell us a little bit about the story of this ranch? This ranch has been in your family for quite some time, hasn't it?
Yeah, my grandparents first came here, my grandfather in 1916. It was then dry land, rolling hills. He started out, we eventually got to a dairy. My dad happened to marry the only daughter, so that's how we got to be here. And it was row crops, alfalfa, corn, and also some replacement heifers. And then about 1970, Dad started planting almonds. By 2001, the entire ranch was in almonds, and starting in 2012, I think it was, we started replanting. We've replanted 2 of the original fields that Dad has replanted, but we're all almonds.
So those and those Butte Padres from '97 are still out there?
Yep, they've probably only got another year or two, but they're still producing well, and it's kind of hard to take them out when you're making money on them.
Yeah, then you gotta wait another 4 years or so to start making money again.
That's right.
And so you how long have you been farming the ranch? How long have you been?
My brother and I took over in 1997.
Okay, so
We have been growing and learning how to grow almonds since then.
yeah, well, 23 years. And so when you took over, you had basically the Butte Padres, and then you were part of the planting of the nonpareil, the Carmels, nonpareil Monterey's, and I assume that the Aldrich and the newer varieties later on.
The Butte Padres show up there as the oldest, but there was nonpareils planted in 1970. We made them last about 29 years before we took them out. But the original plantings were solid set sprinklers. Then starting with the 97 Butte Padres, it was micro sprinklers. And then it wasn't until we got to the 2015 planting that we went that we have basically four sets out in the field. There's east and west of the nonpareil rows and east and west of the pollinator rows.
And so what year did you guys get to convert everything to drip?
That would have been it would have been 14. Okay.
So that was a process that came before incorporating the automation.
Oh yeah, yeah. I take that back. It was 16 that we put in the double line drip, because we were doing them basically concurrently. You were doing the work for us, and we were starting to convert to the double line drip.
Yeah, I remember some of those blocks on the northeast where they still had those big impact sprinklers there. And out of these varieties, which one would you say were the easiest, or what's your favorite one?
Well, I like the nonpareils. My favorite nut was the Carmel, but Carmels will break your heart because of crazy top and other problems with them. So it's still the nonpareil, and I'm kind of warming to the Aldrich and Wood Colony as a pollinator.
And then there's a practice that you guys started doing that was burying the lines.
Yeah, we got tired of plugging holes from, we're not sure, birds, animals, whatever. Just it was more than a full-time job, because quite honestly, we did not keep up with it. And so we got the bright idea one year, well, let's try burying them. And
only 3-4 inches, that's it.
Really only about 2 inches if we were right on. I mean, it was anything between 1 and 3 inches, to be perfectly honest, but the goal was 2.
Gotcha. And did that solve the problem?
Oh yeah, I mean, you still have gophers, but gophers were nowhere near the problem that the animals were. And kind of a side benefit, we didn't have near as much water up on the surface, so it actually helped with weed control. I think it helped reduce the humidity in the orchard. So there were some benefits. And another benefit that we hadn't planned on, but with the double line drip and the pulse irrigation, we were able to go out and do our sprays or any orchard operation that we wanted to at any time. It wasn't a matter of, well, we can't irrigate tonight, or we got to wait till tomorrow for the floor to dry. And during harvest, we'd shut the water off a day before we'd shake, and just as quick as we could sweep the nuts off the berm, we started water back up.
Beautiful. Beautiful. I don't know if I've seen that in many places. Now, you guys have a setup there that it's 60 valves on 170 acres. That is not what you usually see on the San Joaquin Valley. Why? How did that turn out to be like that?
Well, I mean, it started out, we wanted small sets. The Dixieland areas where we farm, it is an okay water area. It is not a very strong water area. If you run your pump somewhere between around 500 gallons a minute, the wells hold fine. We don't see a lot of trouble with the levels dropping. So we set all our sets up to be 500 gallon a minute sets. And so there's 12 sets there. And the reason for all the valves is all the sets have multiple valves. It was just the way the sets were originally designed, and we just automated what was there. Reality is we probably could have went in and replumbed some of this and cut the valves back. But at the time, we kind of thought the valves were cheaper than replumbing the whole system.
And it might be, and it still gives you the flexibility. I mean, not if you're running them manually, don't get me wrong. If you need to open and close 60 valves by hand, it's a pain. But when you automate, then you have more blocks, you have more flexibility. If you have less water, you can run smaller blocks. If you have different soil types, you can start separating the soil types based on the little blocks that you have and mix those soil types that are the same on one set and separate soil types. So we've seen some benefits of having more valves. Usually also there's an energy benefit of having, a bigger pipe and a lot of small valves. So there's less friction, less energy consumption. So we've seen some benefits of having more valves in the field. The problem is the operation, and that is where it gets complicated. And that takes me to the next slide. So I was going to tell a little bit the story. Maybe you can correct me if I'm wrong here, but so you used to irrigate before, going into, and you said it, going into the drip, you were doing micro and solid set sprinklers and flooding, running 12 to 24 hours until you saw runoffs, which is a very common practice, and a lot of people do that still today. And over time, you were converting over to drip. Now, there is part of the story, which I think it was a breaking point, because you had 2 wells and you were running at about 1,000 gallons per minute. You said it on the video with these traditional run times and frequencies. But then I understand that in June 2015, you guys lost the well. So
yeah,
what happened with that well?
We were fortunate in that it was a mechanical problem and not the well going dry. So, but we were 5 weeks getting parts because, if you'll remember, that was during the height of the drought, and finding replacement parts was a matter of waiting. And what when talking with some people, they said, well, just put a little water across it as often as you can. Well, we were at the point we had Rainbird cyclic valves there, but they're
here in the picture. On the picture, people can see it.
They were okay. They're nothing to what you'd want to do here, because you've got to go around and manually set those, and they don't keep time really well. So as the weeks go on, the valves start separating their time. Anyway, it was possible. We went to 4-hour sets and did that for, like I say, 5 weeks, and we're amazed at how well the trees held up, because we were just sure it was going to be a total disaster. And our yield was down perhaps a little, but not much, not like we were afraid. And so that kind of said, hey, maybe there is something we need to learn here. And we started looking around. And it was about that time that we ran into WiseCon. And that was a real savior for us, a real blessing, a beginning of a strong learning curve.
I remember the time, and I remember seeing those cyclics once when I visited the ranch. So basically we went from 1,000 gallons per minute to 500 gallons per minute, running traditional run times 12 to 24 hours, to running a couple of times a day with those cyclics. And I remember one of the headaches that maybe Dan mentioned, that he had to run around in his quad and reset the cycles and reset the time, and the batteries needed to be changed. But the concept was there, and you guys proved the concept. So that was interesting, and I think that and I have it here, impressed with the results and reaction of the trees. The decision is you guys continue to run high frequency irrigation or pulse irrigation, and that's until today, right? That hasn't really changed.
Correct.
So, but as you were saying, due to intensive labor required and low margin for error, that's another thing I would like to discuss on this specific strategy. You guys decided to invest on the Wisecon platform in order to do the valve control and run everything from the iPad. Now, the low margin for error, where did you see that low margin for error? Did you have any experiences where you saw, oh, okay, I gotta be careful here because, you know, if I make a mistake, how did you find that out? I mean, I assume it's the hard way.
Well, we were very fortunate. What we did learn was, especially, it's true with the high frequency irrigation, you do not have a lot of reserve water in your soil because you're meeting the need on a daily basis. So that means that you need to be consistent with your irrigations. There were a couple of times where we had to shut down a day or two, and we could start to see the trees showing rather, well, for us, rather dramatically, as opposed to if you're watering once every 8 to 10 days, if you're one more day, well, it's kind of, you don't really see it, but you will with the high frequency. But what we also saw with the high frequency, and a huge benefit, was we have a couple of fields where there was some real sandy areas. We brought the yields up in those sandy areas to the same level as we saw in our good, quote unquote, good dirt, the dirt that would hold water. So without doing it, without applying any extra water, without doing anything different other than the pulse irrigation, some areas experience probably a 30 or 40% increase in yield.
Wow, that is incredible. That pays for that investment on its own.
Absolutely.
In a year. Well, and that makes a total sense. I've run into other growers south of Chowchilla. We got a couple in the Goshen area right now, and we got in Lemoore, some growers with pistachios that are trying the same concept. The fact that you have different soil types, so the sand likes high frequency, so short durations very often. The clay, yeah, it will allow you to run a longer run and let it go a couple, few days, and then you can irrigate again, but the sand won't let you do that. So when you're running everything on high frequency, now you are putting, it's going to, you're irrigating the worst soil, but the clay is not hurting with that. The clay is still getting it water it needs, it holds it, so you don't have a problem there, right? Unless you have some kind of sealing problem and the water's running off, or you have a sealed soil, which is another thing that, some people discuss. But when you're aiming at that light soil and you're irrigating that light soil, that heavy soil is happy as well. So everybody's happy, just to put it in a way. I've heard people say, it doesn't matter my soil type. I don't care about my soil type. I'm doing high frequency irrigation, so I'm aiming at my bad soil, my bad dirt, as you say. And my good dirt is happy too. So that makes total sense.
When you're irrigating, you're looking at what your ET is, and that's what you're trying to replenish. So it'd be difficult to over irrigate at that point.
Yeah. And when you were irrigating, did you try to keep a specific crop coefficient constantly throughout the year, throughout the season? Did you change your aim based on phenology stages? How did you correlate, as you said, this pulse irrigation or the amount of water that you're putting out with ET?
We took a university ET chart for almonds, and we left it alone. I mean, for us, January, February, March, is, depending on rains, is not much water. But beginning in March, April, especially April and May, we probably bumped that up about 20%. We overwatered according to their, ET chart. When we get to the end of June, the beginning of July, we actually dropped about 20%. Mm-hmm. The theory that we were working on, as it was explained to us, the trees are not quite as efficient in March and April, and they're also working extremely hard. By the time you get to July, the tree is actually kind of coasting, crop is made, things are drying down. So we reduced our water usage those months and saw no detriment.
Wow. So that means maybe if you want to save water, you want to save it towards July, towards the end, after the fruit is set.
And another thing nice about this high frequency irrigation, if the university recommends you cut back for hull split 5 to 10%. Well, it's real easy when you're watering every day to figure out what 5% of your water is and just cut that back. And it does help it. It's an easy decision to execute, and you're consistent through there, so your trees never suffer.
So you're irrigating 10 times a day. You start irrigating 9 or 8. not a lot.
Or go from 30 minutes to 28 minutes or 27 minutes with your system. Beautiful.
Yeah, if you're doing it that precise, you have that capability. But overall, towards the whole year, would you say that, or the whole season, would you say that your overall crop coefficient was 1.9, 1.1? Where would you say you were? I know it changes during each year, maybe, but
I'm gonna throw that question back to you. I'm gonna tell you that we felt we did extremely well and could have done better, but somewhere in the 40 to 44 inch water usage for the year, where the university is going to tell you 54. So, I don't crop coefficient. I'm not that person.
Oh, fair enough. And that is throughout the whole year. Did you ever start irrigating in January, February, especially during the drought years? Did you guys irrigate?
Absolutely, because January and February is a time you can get deep moisture in. Once the tree starts, at least in our ground, you're not going to put deep moisture in. And the importance of the deep moisture is that's the tree's security blanket. As long as it's there, it's happy. It's not gonna react.
Interesting. Well, so today, and I want to show this picture a little bit so people understand. Looking at the ranch, we saw the first picture. This is what was deployed back in 2015, I think, when you guys invested in the telemetry and the automation system. We deployed 28 nodes to operate the 60 valves, 2 flow meters there on the 2 propane pumps, 4 pressure transducers to monitor pressure before and after the filter, 7 soil moisture probes that you had originally from another system that you had used, and we're going to get into that in the conversation at the end. 3 weather stations, which is actually quite impressive on 170 acres. Usually you barely see one on a ranch, but it's good to compare temperatures, and I've seen very different, for example, rain information on a 170 acre ranch. If you put 2 rain buckets, you get completely different readings. It's incredible. It's just how those clouds move. Sometimes you get a piece, especially like this piece, let's say in the southeast of the ranch, completely different from the northwest. Then the Simis weather station, the Madeira we were using, I understand, on your ranch. Then we had a canal level monitoring sensor. People don't know if people can see it, but here on the south side of the ranch, there is a canal, and that's a dead end of a canal, correct?
Correct.
And you decided to put a level sensor there on that canal. Why was that?
We got tired of having to run down there. The irrigation district just seemed to have a lot of trouble maintaining a canal level there. And if it goes low, our pump ran out, and when it runs over, it floods us. So we did something about it. When it got too high or too low, it notified us, and we could do something about it.
So you take your own control over your own destiny.
Yeah.
Okay, and then we were calculating there chill hours, chill portions, degree days. Did you use those variables? How did you use those variables that we were calculating for you at some point?
Did I do a lot with them? No, but we compared, we looked at those and then looked at how the crop was progressing, looked at the yields at the end of the year. It's just more information to throw into the mix and try and see. We don't have any control over chill hours, but it's interesting to see disease pressure and yields when you look at good chill hours versus low or whatever.
So now if you look back, or if you would have to make this decision again of what you guys got on the automation side, on the equipment, on the sensors, would you change anything? Would you add anything? Would you maybe not buy something out of this list?
No, I would actually, and I'm sure you're aware, we added a bunch of soil moisture probes a couple of years ago. But I think the thing that I would do different is the NVDI or soil leaf. I just think we can learn more sooner. Soil moisture is a lag reading because the tree has already used the moisture out of the ground when that probe drops. But I think there's more to be learned out of the NDVI or leaf temperature. My goal is to maintain as even a moisture in those trees as possible, because it just seems to me that's going to give me the best growth and the best crop.
So you mentioned you mentioned that you added some moisture sensors. Now, why was that? I mean, you already had 7 on 170 acres. Don't get me wrong. If you want to buy more sensors, we're happy to install more. But what was the reasoning behind that?
Because what I did is I put them in the 3 varieties in the new field we planted. I wanted to watch water usage, in particular around hull split and harvest, to see what was going on in the ground with the trees. Because most of our knowledge is based on the nonpareils, but all the other varieties use different amounts of water at different times. And if we're going to learn and increase yields, we need to know when we need to water these trees more.
Now, but you did not plumb your systems in a way where you could irrigate different varieties, did you?
In blocks 1 and 2, yes, I can water nonpareils and I can water pollinators separately.
And do you do that? Do you use that differentiated irrigation throughout the year, or just for, like, when you're harvesting the pollinators, you're irrigating the nonpareils and vice versa, or do you actually change the strategy throughout the season?
We're learning. I mean, those are young trees, so it's still a learning process there. It's real handy at harvest. I mean, I don't know. I do know that wood colony require more water, so that's something that we're going to be watching, and that's why I've been told wood colonies require more water during August. That's the reason for the extra probes to verify.
Okay, understood. Yeah, verification, and then you can give that extra boost because you have that plumbing where you can make that specific variety. Now, but something that I've seen in other ranches and we've done in other places is that you do irrigate them daily or differentiated for harvest. I mean, if you're drying out whatever you're going to shake, you still irrigate the other variety.
Yeah, still irrigate.
That is a benefit on its own right there.
Absolutely.
Well, and here on the screen right now, I'm showing a little bit on how Tom's scheduling looks. So you can see the smaller blocks. You're running 1, 2, 3, 4, 5, 6, 7, 8, 9 times a day for what seems to be 20 to 30 minutes. And then the older trees, you're at an hour, 3 times a day. At least this is a graphic of 2017. I should update this to something newer, but this is June 11th, 2017, and you've been doing this for years, and there's a lot of information on the platform on your ranch. Is this something, does it look like what you guys are doing today?
They've it's changed a little. It's going to evolve over time. I mean, and just because I think something's a wonderful idea today, I may figure out it's not next year. So I think one of the dangers we fall into is we've always done it this way. We need to be thinking about what we're doing. Sigma is going to drive some major changes in how we irrigate and what we do. And that's why I think with the system that you have, we can innovate. I mean, I still think that we could possibly get this down to 36 inches of water a year. Yeah. It's going to require really paying attention, to ETs and everything. But we don't know what we can do until we do it.
And on some of the registry of the years, I think, especially on the drought years, I think we do have a year or so that you were around those numbers. 6.
Yeah.
Because I was looking at the past data while, updating the presentation, and I saw a couple of years that came down to 36. That's quite impressive. I mean, of course, when you have the drought and you don't have any surface water, and you're forced to do it, The thing is that you can actually manage your crop and get a good yield with that level of water.
Yes.
Well, and here, what I'm showing now, it's as I said, and I put your words here. This is a very intense irrigation method. You're irrigating every day. You're irrigating several times a day. You're constantly looking at your soil moisture sensors, so you validate what's going underground. Here you can clearly see with this high frequency that the water tends to get to the lower depths. This red sensor is the 16-inch sensor, 22-inch, and the 36-inch sensor. So you can clearly see, and this is in June, between between May 18th and June 15th. So it's a month between May and June. And you can see that the water is, coming in all the way down to the first 15, 16 inches on every irrigation, and the water is maintaining on the lower depths, but you're not irrigating that deep. So as you were saying, you don't have that reserve, that water tank below the root zone. And you are keeping your active root zones up on the shallow first, foot and a half. So that is what's happening. I mean, the roots are going to be where you put the water, and that's what you've been doing here. So very important moisture sensors when you're doing this high frequency irrigation to validate what's going on. Constant weather station data helps. I have here the temperature trends. I remember you told me that. What is that? Is it for planning ahead, or what do you again? Where do you use that temperature information?
It's just part of the mix that we look at when we're making a decision. My brother spends more time out in the orchard than I do, and we get together and what is he seeing? What do I see here? And combine that knowledge, because you have to ground truth everything that you see on the chart, so you know what is going on out in the field. Just looking at the chart, you're not going to truly know. You need to combine them both to have a comfort level and to know what you're doing is making the best decision.
Absolutely. But going back to these temperature trends, I mean, when you're looking at forecast and you see that your temperature next week, you do put and add a few minutes to your pulses, and you kind of prepare your soil. Although you don't have that reserve, you're still ready to put a little longer shots of water to make sure that temperature doesn't strike you and take up all your water. What
we've observed is, as long as our temperatures stay 100 or below, we've not had to add extra water. It's those, really hot spells that come along, 103, 105 for a few days, then we need to step up.
No, okay. That's kind of where I wanted to get that 100-degree point. Everybody freaks out with that, and I mean with reason. But I've seen also people go out and put 48 hours of water. I'm like, water 10 feet under. I mean, this is not helping. Frequency is very important. And then, well, you were saying rely on visual inspection and what Stan's been doing and spending time in the ranch. So overall, what we've seen, and I put a picture here. If you remember, we had the UCNR guys and the almond board guys. When they heard this presentation the first time, they said, no, we want to go see it. So I don't know if you remember that day, I was taking these pictures. They got out of their trucks with their pressure bombs and their augers. They're like, and actually I remember the words that I think it was either Blake or maybe Spence said, you guys brought us to the University of Irrigating Almonds in California. They were very impressed with what you were doing. Actually, those trees are only the third leaf, I think, because we were standing on block 2.
Block 1.
So it was very impressive, and we've had these guys come out there and check and see, and understand how this high frequency is actually working. Overall, you guys, everybody heard it on the video, it's 170 acres with 600 gallons per minute. Something between 36 and 44 inches is the information that I had, depending on the year, around 30% water savings to what you were doing before. averaging about 3,000 pounds per acre, considering, there are some older varieties, that you said those, Carmels, and sometimes give you a hard time, but average overall, it's a very good production. Time saving, I mean, we should ask Dan that, but I remember every time he saw me, it was like, you're saving me a lot of time. There was sometime he had to wake up in the morning and go switch the valves and all that. And the even water, you always talk about those benefits, no ponding, no runoffs, and even the fact that you guys can be shaking one day after stopping the water, that's just incredible. So yeah, this is when they visited in 2018 and validated how this irrigation strategy was going. And that's why I mentioned at the beginning, actually I'm meeting them this afternoon, because they want to understand a little bit better and get into it and understand it at the almond board in order to, bring this down and do the diffuse, extension of this knowledge and strategy on some of the grounds. It depends on soil types. It depends on if you have a flat ground. Of course, it depends on your reality. But you are there in a very average position in the Central Valley that could work for a lot of almond growers. And here I just finish up this presentation with some of the stuff I found in the media from you. We got the growing produce, that's actually The Economist. So very interesting. It's very interesting, and we're very, very, very happy and proud to work with you guys, work with you guys throughout this few years, trying to be on the cutting edge of technology, and a technology that's that's reliable, that you can rely on. There's a support team behind it, and of course the fact that it's simple to use, that can be used by anyone basically. So that's what I had on the presentation side. I think we only have a few minutes left. And we've discussed a lot of topics. I guess one of the things I would like to probably ask you at this point would be, how did you get started on this technology trip? Because I remember that you used maybe Pure Sense at some point and other solutions out there. So how did you decide to get into technology? What would you say to a grower that's today, flipping valves, butterfly valves by hand, or has his irrigator in the field, hasn't used soil moisture probes, and doesn't have, a sense of what the technology does? How did you make that decision to start testing technology?
Well, we were really fortunate because Dad would look at just about anything that came along, and we had the old moisture probes that you had to fill and vacuum, create a vacuum end to use. So we learned from that early on. There was a couple of times when they told us to water, and we went ahead and watered, and it made such a tremendous difference in the crop. We just realized that we didn't know as much as we like to think we do, and we needed to improve what we're doing. And I mean, it's even more true today, because with Sigma and everything, if you're not measuring and irrigating on a really precise schedule, you're wasting water and time. And I don't think there's anybody has enough of that. I'd rather have my man checking water than changing water, because he's going to make me more money by seeing that the system is operating at peak performance rather than just going around and flipping a valve. And
that's something that a machine can do today. I mean, automation has proven, there was some failed attempts in the past, and we understand that. But nowadays, we got a lot of guys that are running off peak to save energy, and they're running at night, and you don't need a guy for that. The guy, but you still need the guy to be out there to check cloggings, to flush lines, to check on the trees. You need that visual and checking in the field for sure. But the responsibility of how long and how frequent to run is not on that guy anymore. Now it's on a computer. So the computer doesn't make a mistake. A computer doesn't come in late. A computer doesn't have a commitment or an errand. The computer will start and stop at the time that you told it to. Now, do you think that the implementation of the technology was that hard for you guys? How do you feel that a grower, that fears potentially investing in this and failing at it? what would they have to consider, or what should drive their decision today?
I think to do the best job with the tools that you're given. I just think that to be able to control your water so precisely, to not have to worry about, well, did my man make it to open a gate? Did something happen? Did another errand come up and he got pulled off? So instead of running two 12-hour sets, I ran a 14 and a 10. That will make a huge difference in your fields, because 2 extra hours is a waste of water, and 2 hours short may make the difference between having a good crop and not.
Yeah, absolutely. Absolutely. Do you think
We did get a question from a guy who asked, with the Independence variety, he has the potted trees that were planted June 1st. He was wondering how often and how long you should irrigate double line drip for those Independence varieties.
If you're willing to, we raised ours on 20 minutes a day, every day, realizing they don't have a lot of root mass. So just a little bit of water each day, the trees were happy. It wasn't until the end of the second year, about July or August, that I actually went up to 30 minutes a day on my young trees.
Gotcha. Thanks.
Well, I think we're on time. So, at this point, I would just basically like to ask, thank you, Tom, for participating in this. We're getting on, starting off with this, getting growers coming in and telling us their story, and we see a wide difference between, as I said, some growers that are running everything manually and have a guy running around open and closing valves, and some other guys like you that are running 10 times a day and monitoring 10, 12, 15 soil moisture sensors in 170 acres. So we're trying to help close that gap and by being the growers, telling the growers how to use the technology, how to implement it, and not to be afraid of it, because we've seen a lot of success cases come around. So thank you very much for your time. Thank you very much for taking the time, and yeah, let me know if I can be of any help, or I hope I see you soon.
Yeah.
When again this not new normal is gone. Yeah. I'll be around and maybe stop by and
please do. Please do.
Thank you for your time.
Care.
You too, man. Thank you very much.
Thanks, guys. Yeah.
Bye-bye.